Good morning, dear students. Now, after the combination of cell resistance, let us now learn about the combination of cells or grouping of cells. We can group them in series as well as parallel. So, first, let us see cells in series. So, if we consider n number of cells of having EMF E1, E2, E3, dash En are joined n to n, as shown in the diagram, then this type of connection is called as series connection. This is E1, internal resistance R1, E2, R2, E3, R3, and dash En, Rn. Okay, so if between A and B, if the batteries of EMF E1, E2, E3, dash En are connected, so this arrangement is called as series arrangement. Okay, so if we use our normal equation also to write, so we can simply write this as E equivalent is equals to E1 plus E2 plus E3 plus En. This is the net EMF, and the equivalent resistance the equivalent resistance can be given as these resistances are in series. We can give that equivalent resistance R equivalent, small r equivalent, equals to R1 plus R2 plus Rn. If all the cells are having same EMF, if all the cells are having same EMF, let it be say E, same EMF E, and internal resistance is also same. Internal resistance is also same, that is small r. Then E equivalent will be equals to n times E, and small r equivalent equals to n times r. Okay, so the equation for current that we have derived already, I equals to E upon capital R plus small r. This was the equation that we have derived. So this equation for the group of cells when this is connected to external resistance R, right? R is the external resistance. So if these cells of internal resistance R are connected to a external resistor R as shown, okay, this is point A, this is point B. All the cells have EMF E, and the internal resistance across R, all the cells is R. Then this equation can be written as I is equals to N into E upon R plus small n times R. This is the total current flowing through this circuit. Now here we have some conditions that if, now the equation I will write it here for my reference, that is N into E upon R plus N into R. Okay, now in this we have two conditions. First, if N into R is very smaller than capital R, means R is very much bigger than N into R, the internal resistance of cell are very small, and N times R is also very small, then I can neglect NR. So the equation can be written as I is equals to N into E upon R. Okay, fine. Now this series combination is advantageous. So this series combination is advantageous. Why? Because we have N times E, the current is more in this case, so N times E upon R. Okay, now if in the second part, in the second case, if I will take N into R is very much greater than R, such that R can be neglected, capital R can be neglected, it is so small. So I will be equals to N into E upon N into R. So this will be E by R. So definitely this is not that advantageous as the above one, right? So this series combination is not advantageous. Okay, now one note you can write down in this case as a simple note: if out of n number of EMF batteries, n number of cells, m cells are connected in opposite direction, are connected with polarity reverse. Okay, so the total or the equivalent EMF will be simply N into E minus 2M into E. Okay, so this will be N minus 2M into E, but the equivalent resistance will be simply N times R plus R. So the current I will be given as N minus 2M upon NR plus R into E. So this is when polarity of M cells is reversed. Okay, I hope you understood this much.